Hello everyone, this is Peter from Learnwithuncletee and you are welcome to this tutorial. In this tutorial, we're going to be discussing the integration by algebraic substitution. So now, one thing we need to understand is that sometimes we might want to solve integration problems whereby we'll have to leave the function as a standard form by making an appropriate substitution. So to understand this better, let's go straight into a question. So let's assume that we have a question. Let me see example one. Now the question says that we should evaluate integral x multiplied by e raised to the power of x squared dx. Now take a look at this question. We have x times e raised to the power x squared dx. Now if you decide to say that let u to be equal to x, you know that when you find your du dx, you're going to get 1. And if you introduce it here, you are still going to have a complex structure. It won't look like a standard form. A standard form for this question is when you have x, or let's say when you have just e raised by x. So it means that our focus here should be on this e. And this e is raised to the power of x squared. We want to leave it in terms of, let's say, e raised by x, e raised by u, e raised by p, or depending on the letter you want to use. So you discover that when you differentiate x squared, you're going to get 2x. And you know that that 2x will be coming as an inverse, which can eventually cancel out this x. So it means that the most viable option here is to say that let u to be equal to x squared. So if u is equal to x squared, du dx is going to give us 2x. If you make dx the sort of formula, dx will therefore give us du divided by what? Divided by 2. So it means that integral x e raised to power x squared dx is now equivalent to integral x multiplied by e raised to power x squared, which is now u, multiplied by dx. Our dx is now what? Du divided by what? Du divided by 2x. So sorry, when you make the formula here, you get du over 2x. So du divided by 2x. So from here, x multiplied by this x will cancel out. What will be left is 1 over 2. So we can factorize that 1 over 2 out. This will give us 1 over 2 integral e raised to power u du. So this will give us 1 over 2 integral. So don't forget, we can remove the integral. If you integrate e raised to power u, you're still going to get e raised to power of u plus arbitrary constant c. So therefore, this is 1 over 2 e raised to power, our u is what? X squared. 1 over 2 e raised to power x squared plus arbitrary constant c. That will be the final answer to that question. Let's consider another example. Let's say example 2. So for example 2, let's assume that we are to evaluate integral x squared multiplied by cos x raised to power 3 dx. So we want to evaluate integral x squared multiplied by cos x raised to power 3 dx. The standard form of cos here will be just cos x. So let's see how we can reduce this. So if we say that let u to be equal to x raised to power of 3, it means that du dx will give us 3x squared, which therefore means that dx will give us du divided by what? Divided by 3x squared. So it means that integral x squared cos x raised to power 3 dx will give us integral x squared cos x raised to power 3 now is u. So that's cos u multiplied by dx. Our dx is now what? Du divided by what? 3x squared. So x squared will cancel x squared. We'll be left with 1 over 3. We can factorize it out. So that will be 1 over 3 integral cos u du. So which will give us 1 over 3. If we integrate cos, you're going to get sine. So that will be sine u. And our u is what? X raised to the power of 3 plus an arbitrary constant c. And that will be the answer to that question. So let's take another example. So let's say example 3. Evaluate integral x multiplied by root 1 plus x squared dx. So now take a look at this. You can still use application because when you differentiate 1 plus x squared, you're going to get 2x, which will still cancel out this x. So I think we are getting the concept now. When we're to integrate integral x squared cos x raised to power 3, we differentiate x raised to power 3, you get 3x squared. You have an x squared that will cancel out this x squared. So that's more like the basic concept of algebraic substitution. So if we say that let u to be equal to 1 plus x squared, our du dx, when you differentiate 1 plus x squared, you are going to get 2x. If you make dx the sort of formula, you are going to get du divided by 2x. So therefore, it means that integral x root 1 plus x squared dx will now give us integral x multiplied by root 1 plus x squared is now u, and that will be square root of u, so which we can represent as u raised to power 1 over 2 dx. Our dx is now what? Multiplied by du over what? Over 2x. So x we cancel x, we can factorize 1 over 2 out. So that will be 1 over 2 integral u raised to power 1 over 2 du. So if we integrate that, that will be 1 over 2 integral. Oh, sorry. When you integrate it, that will be, you add 1 to the power, that will be 3 over 2. You divide by that new power, so that will be times 2 over 3. So you know that's divided by 3 over 2. So but when you take the reciprocal, it gives you 2 over 3 plus an arbitrary constant c. So this will therefore give us 2, we can still cancel 2. So we'll be left with 1 over 3 u raised to power 3 over 2. But our u is what? 1 plus x squared raised to the power of 3 over 2 plus an arbitrary constant c. And that will be the final answer to that question. 1 over 3 times 1 plus x squared raised to the power of 3 over 2 plus c. So let's take another example. Example 4. We are to evaluate integral x squared multiplied by 3 plus x raised to the power of 3 raised to the power of 3 over 2 dx. So same concept. We'll take u to be what is inside the bracket here. So we have u is equal to 3 plus x raised to the power of 3. Therefore, it means that if we have to find du dx here, our du dx will give us 3x squared. So if you make your dx the serial formula, dx will give us du divided by what? 3x squared. So our dx is equal to du divided by 3x squared. So it therefore means that integral x squared into 3 plus x raised to power 3 raised to power of 3 over 2 dx will therefore give us integral x squared multiplied by 3 plus x raised to the power 3 is now u raised to the power of 3 divided by 2 multiplied by dx, which is now du divided by 3x squared. So x squared will cancel x squared. We can factorize 1 over 3 out. That will give us 1 over 3 integral u raised to the power 3 over 2 du. So this will give us 1 over 3 times u raised to the power. If you add 1 to the power, so that will be 1.5 plus 1, which is 2.5. 2.5, that's 5 over 2. So that will be 5 over 2. So that's just 3 over 2 plus 1 divided by 5 over 2, which will be times 2 over 5 plus an arbitrary constant c. So what it therefore means is that we are going to have 1 over 3 times 2 over 5 will give us 2 divided by 15 u raised to the power of 5 over 2 plus an arbitrary constant c. So this is 2 divided by 15. Our u is what? 3 plus x raised to the power 3. Everything raised to the power of 5 over 2 plus an arbitrary constant c. And that will be the final answer to that question. So let's take one more example. So example 5, we have integral e raised to the power of x multiplied by 3 plus e raised to the power of x raised to the power of 4 dx. So now you discover that if we take u to be 3 plus e raised to the power x, if we differentiate it, we are still going to get e raised to the power x, which will be able to cancel these out. So let's take our u, let u to be equal to 3 plus e raised to the power of x. So from here, it means that du dx is going to give us e raised to the power of x. Then dx will give us du divided by what? E raised to the power of x. So it therefore means that integral e raised to the power of x into 3 plus e raised to the power of x raised to the power of 4 dx will give us integral e raised to the power of x. 3 plus e raised to the power of x now is u. So that is times u raised to the power of 4 times dx, which is now du divided by what? E raised to the power x. So e raised to the power x, we cancel e raised to the power x. We are going to be left with integral u raised to the power 4 du. Integral u raised to the power 4 du is going to give us u raised to the power 5 divided by 5 plus arbitrary constant c. So since our u is 3 plus e raised to the power x, we substitute back 3 plus e raised to the power of x raised to the power of 5 divided by 5 plus an arbitrary constant c. And that is going to be the final answer to that question. So for this tutorial, this is where we're going to bring this tutorial to an end. Once again, this is Peter from Learnwithuncletee. If you have not subscribed to this channel, you can do that now. See you in the next tutorial. Thank you.